Sample question number 20 here is, this will be question number 20. Electrons in an X-ray imaging medical equipment are accelerated from the rest through a potential difference of 65 kilovolt. What is the average speed of each of these electrons? The question is about what is the average speed of individual electrons. So as they have given us the voltage and the question is talking about the electrons and all, we need to relate to find the speed of the electron. We have to write the formula. This question is depending on the work energy theorem. So what actually the work energy theorem says, the total amount of work done is basically equal to the change in the kinetic energy. That's what the work energy theorem says. Now how do we represent the work here? When we are talking in terms of electron and the voltages, the amount of work done will be equal to the value of the electron, that's charge multiplied by the potential difference, or the charge multiplied by the voltage. And we also know the kinetic energy, the change in the kinetic energy will be written as half mv square, where v is the speed of the electron, m is the mass of the electron, and that's how do we represent the kinetic energy. According to the work energy theorem, these two quantities are equal. It means I can calculate what is the speed of the electron. But here there is m. So what is the, because according to this, I will be knowing the voltage. So V which has been given to us is like 65 kilovolt. And the charge of the electron, we know that 1.6 into 10 to the power negative 19. But what is the mass? Mass is m is representing the mass of the electron, and the mass of the electron is 9.109 into 10 to the power negative 31 kg. This is the mass of the electron. So substitute all these values and let's first calculate what is the speed of the electron. First, let's try. I can write this equation here as Q times V is equals to half mv square. So don't try to cancel this capital V and this V, because this V is representing the voltage and this is talking about the speed. Let's first arrange this equation before substitution. Take this 2 to this side, then it can be written as 2qv is equals to mv square. As we have to solve for v, so divide both the side by m, so both the side by m, so then it's gonna be, it gives us, so 2q capital V divided by m is equals to v square. But actually we are solving for the v. How do you go from the v square to v? By taking the square root on both the side. So when you take the square root of this, then we got it here as square root of 2qv divided by m. So this m is also under the square root. Okay, so square root of 2qv divided by m is equals to the speed. Now substitute their values. When you substitute their values, then it becomes a square root of, let me just write it a little bigger, 2 times the charge of electron is going to be 1.6 into 10 to the power negative 19. Voltage is going to be 65 kilovolt. So 65 into 10 to the power 3 kilo. And we know that this entire result divided by the mass of the electron. Mass of the electron, as we mentioned, 9.109 into 10 to the power negative 31. That is equals to the speed of the electron. Now, if you insert these values as it is in your calculator, the speed of the electron after putting it in the calculator will be getting it as 1.511 into 10 to the power 8 meter per second. This is the speed of the electron. Okay, this is the speed of the electron. But if you look into the question, this one is also available option. So 1.51 into 10 to the power 8 meter per second. But the question is not asking about the speed of the electron. Question is asking about what is the average speed of the each electron. So how do I calculate the speed of this electron into the average speed? How do we calculate? Average speed of each electron can be written as speed of the electron, speed of electrons divided by the number of electrons. So number of electrons. So how many electrons has been ejected? So we have to calculate to find the average speed of the electron. So We know that the speed of the electron, we got it as 1.511 into 10 to the power 8. So this is simply done here as 1.511 into 10 to the power 8 divided by the number of electrons. So how many electrons are there? Let's calculate number of electrons. So how do we calculate the electrons? So look at, as we are saying that electrons are emerged from the X-ray and they are falling on the equipment or the certain material, it means there is some amount of work has been done. And the amount of work done can also be written as the number of electron multiplied by the charge of each electron. So I can say in terms of this, work done can also be written as W, can also be written as the number of electrons multiplied with the charge of each electron, charge of each electrons. This is can be written, and we know that the work done in terms of the charge and the voltage can be written as Q into V is equals to number of electrons times the charge of the each electron is going to be the Q. So that this is the charge of the electron. So in this case, what we are getting, cancel out this charge and this charge. We can say the number of electrons is equals to the, what is the value of voltage? Number of electron is equals to the how many voltage that has a potential difference. So we know that the potential difference is 65,000 or 65 kilovolt or 65,000 volt. So the number of electrons are also equal to 65,000 here. 65 number of electrons are there. So now substitute the number of electrons value here. Then your equation becomes 1.511 into 10 to the power 8 divided by 65,000. That gives you the answer here as whatever the value we're gonna get here as 2.323 into 10 to the power 3 meter per second. So this is the average speed of each electron. So 2.323 into 10 to the power 3 meter per second. This is the average speed. And the question they are asking us about, what is the average speed of the electron? And this is the value, and which option is representing this 2.323 into 10 to the power 3 meter per second. According to the options, this is represented by nearby value. It's option B. This is the answer to the question number 20.